So one question that kind of came up in my mind repeatedly while I was learning is, why don't we see more DPDK in databases? If you look at industrial databases, there isn't actually a lot that use DPDK. And that you'll see a little later why that is such an odd thing. But I would like to, in the venerable tradition, start with a quote that kind of sums up the feelings of the database community around networking right now. So, TCP/IP is a pig. It should be sent to the home for tired software. We need something lighter weight, better, easier to use. Kernel bypass networking would be nice. Michael Stonebreaker at HPTS 24. So you may know Michael Stonebreaker from Postgres, a 2005 IEEE John von Neumann Medal, or his 2014 Turing Award. And the idea of kernel bypass being too hard to be used widely was echoed at that workshop a lot. And that is most of the largest names in databases. RDMA is simply not an option. We can't do RDMA from Virginia to Ireland, and we need geodistribution. And database specialists, they want to use DPDK because it is really the only viable option for something that will run pretty much everywhere and give good performance, but the barriers to entry are too high. So this comment in particular was referencing the kernel TCP stack, but there are frustrations of the kernel TCP stack, and then there's a lot of frustrations that are directly tied to TCP, the protocol. So where is this coming from? If you look here, you'll see a modern distributed database. This is Amazon's DynamoDB. Every single arrow is a network connection, and this is the minimal deployment. So when you are targeting single-digit millisecond response times with multi-data center replication like Amazon does, every single microsecond starts to really count. And TCP is not good for databases when that happens because head-of-line blocking starts to become a major issue. And in addition, the fundamental algorithms of distributed systems are specified in terms of message passing. Logical clocks, Paxos, Raft, etc. So when you have a consensus algorithm, which already provides a significantly stronger ordering than TCP provides, TCP becomes kind of unnecessary overhead. Additionally, it should be remembered that TCP's original goal as a protocol was get the data while sending as few bytes as possible. That is not what databases mostly want to do. They want, give me the lowest latency possible, give me the highest throughput possible. And as a result, they will try to do message passing over TCP, and they face a massive API mismatch. So the logical solution would be, okay, let's use DPDK. We can fix the throughput or the latency issue depending on what your database wants. But it's hard to use, and importantly, it sounds too good to be true. And this is kind of important dual part issue. So a modern programmer is expecting send this blob of bytes to that other server via an encrypted tunnel API. And that is one function without a whole lot of setup. And they are not expecting send these bytes onto the wire, or at a bare minimum, they want an ePOL wrapper, something like Boost ASIO. And second, DPDK is so much faster than normal networking that it sets off too good to be true alarms in everyone's heads, because they see numbers close to RDMA and they assume, oh, it's some exotic hardware. So database people are typically storage specialists or distributed systems specialists, not network specialists. And that means they're not sort of in the right frame of mind for looking at DPDK as I think everyone in this room looks at it. This gets compounded when most network stacks for DPDK implement TCP, which is not great for databases. And the ones that implement message passing are often academic and not really production grade. So a pitch for DPDK very quickly turns into a pitch to write an entire network stack. And that requires more knowledge than a company is willing to invest, because they already think, oh, this is too good to be true, there's no way it can actually do that. So, some of you are thinking DPDK is too fast. So, let's look at Mica. It is, as far as I'm aware, the first data store ever built with DPDK, back in 2014 using DPDK 1.4.1. So, at the time, Memcached was already a production grade cache. And MEMC3, RamCloud, and Mastery were all the top performing things across academia and industry to compare it to. So this is a massive mismatch. This is an 80 times performance increase versus Memcached for functionally the same task. And it's also important to note, Mica is not a distributed database. A distributed database would have a bigger difference here. And much of these performance gains are just from being more efficient at talking to the single client that it's speaking to. So, if you are looking at something which on a dual 8-core Intel Xeon from more than a decade ago, which is outperforming Memcached, you say, okay, let's step ahead 10 years. Still not a great graph for the kernel. So this is an AMD EPYC 9684X. So we have 6x star core count. Our memory has gone up by almost 2 orders of magnitude. And Mica is still 10 times faster after 10 years of hardware development if you compare Mica on original hardware to Memcached on modern hardware. And this is something that happens over and over again. DPDK isn't competitive with a normal Ethernet stack. It's competitive with RDMA and FPGAs in a lot of cases. So managing to be similar to an equal core count CPU a decade later is a big performance win. Managing to match 8x the cores without a socket interconnect a decade later is into, are we sure that benchmark is accurate territory. 10x the throughput of more cores later without a socket interconnect a decade later is frankly unbelievable, and I would be checking the benchmark. So even if we drop performance by 10x to account for good design in Mica, that's still a humongous performance increase. And you can see how someone coming into DPDK, or coming into an organization pitching DPDK, and they say, yeah, we can probably do 10x, 20x what you're doing right now. You have no credibility, and people think, no, that's snake oil. So my solution to this is provide a high-level, easy-to-use interface where DPDK developers can make sort of generically good decisions for users. Many modern applications are built around message passing, not just databases, and most developers don't want to write a network stack. So implementing a DPDK easy mode allows someone to kind of take it and plug it into their code base, whereas a production version of DPDK, sort of the thing that we all build, where you have full control of the network stack, that's really difficult to integrate into an existing code base that wasn't built with DPDK in mind. And that amount of effort is hard to justify almost no matter how much performance you gain. So I think that this will help adoption, and it will help produce more examples of DPDK being fast to help fight against that incredulity problem. So as a design sketch, optionally in-order message passing with multiplexed logical sequences of messages over a connection. Give it the option for, yes, I would like compression, yes, I would like encryption. We can have a discussion about specific protocols later. Reuse send message and receive message. We can change basically everything else, but keep the verbs the same so people have something to latch onto. and then a listen API for new connection handling. Offer an embedded mode via a library, which operates very similar to traditional DPDK, where you take control of all the NICs on the system, and a service mode, which acts as almost a microkernel component. And this means that people don't have to deal with multiprocess, and their application doesn't have to actually include DPDK. It has to include a shim that knows how to talk to the service. Multicast is nice to have, and the goal of this is build something where someone can take DPDK and build a small toy application in a couple days, run it on their own hardware, and see, yes, this is really, really fast. So for prior art for this, there's a lot of TCP stacks out there, but ERPC from data center RPCs can be general and fast, not NXPs, similarly named solution. It's embedded in an application, and it's competitive in terms of functionality and latency with Zookeeper Atomic Broadcast implemented on FPGAs. So that is another example. DPDK isn't competitive with normal Ethernet, it's competitive with FPGAs. And that is 7,000 lines of C++ and has gained a fair amount of popularity inside of academia because it's easy to use and it's fast. MockNet is designed as DPDK as a service. So you deploy it as a container alongside all of your other services, and it co-ops the verbs from POSIX sockets, changes the API, and then you can easily have a half dozen microservices all sharing one NIC and being otherwise mostly independent programs. 11,000 lines of C++. So it's still smaller than libeventive. And both, they're easy to use if you are not a DPDK developer. They're close to RDMA and ROC and latency, close-ish in throughput. And they're based on older versions of DPDK. So I updated MockNet to 23.11, it was 21.11. And these external solutions, they have difficulties evolving alongside DPDK. There's a big group of people here, and without a fairly substantial investment, it is difficult to keep up with DPDK, which is why there is a veritable graveyard of network stacks for DPDK. And they also make the mistake of saying DPDK is the network card accelerator and not actually picking up any of the other useful things that are exposed by DPDK. For instance, they do encryption by calling into OpenSSL normally instead of using cryptodiff. So I think that we, as the DPDK community, can do better than that. We're not the network interface card development kit. We are the data plane development kit. So take advantage of the high-level API, plug in cryptodev, plug in compressdev, plug in DMA dev. Add software fallbacks where necessary to ensure portability. For instance, rename and document DMA/skeleton, etc. So this makes it easier to use DPDK, bringing in new users. And for the users who take a look at that easy mode API and say, actually, we'd like a little more performance. Okay, we're DPDK. We have all the performance that you want. But for most people, they're going to look at that and say, wow, this is really, really, really fast. Also, importantly, versus other protocols, let's actually start from the hardware and work up, instead of something like Quick, which fairly evidently started from HTTP and worked downwards. This means we go figure out what can hardware reasonably do for us and design around that for partial or full offload. And this also helps vendors, because it means that use of new devices that exist under this API are just an update to DPDK. There's no please rewrite your application and replace all of the instances of memcopy with DMA dev calls. And it also makes it easier for vendors to show the value of their hardware once we have a couple applications built on top of this, because you can toggle on and off your hardware and say, okay, let's run Redis with and without this. Let's run say memcached with and without this. Let's run an HTTP server or some other proxy or a VPN. So I think that as a community, DPDK is full of networking experts and people looking towards the future of the field. So let's build something that is designed for the hardware of 2 or 5 years in the future, so that by the time we're done building it, the hardware is here, instead of continuing to make use of protocols that were designed for the hardware of the 1980s. So, thank you. So, yes, please come for questions. I am ready for quite a bit of discussion on this.
Yeah, this is working? Yeah. Martin, have you looked at C-star?
Yes, I have looked at C-star fairly extensively. So C-star architects their network stack in such a way that if your database or application is not structured like ScyllaDB, you start having a lot of API mismatches. And they have kind of bent the entire networking framework towards what is good for their database in particular.
Yeah, it's being used by other things as well and can be extended. The other thing is you mentioned ERPC. ERPC is actually used in Kubernetes pretty heavily. It's a lot more efficient than gRPC, and so like between kubelet and the runtime, for example, and a lot of the plugins, the interface is ERPC. So.
Yes, I was not aware that ERPC was being used in that area. Okay. Any other questions, comments?
Yeah, so when you say that you want some database to work with DPDK, right? Typically, like, does that mean getting an existing database and like having a DPDK layer with a shim that, like, the same as what the previous presenter kind of presented, right? Is it the same thing or something different?
In order to port something to this, you would still need to go kind of rip out the existing network stack and replace it with message passing. But most databases that I have looked into, and indeed a lot of normal applications, communicate over discrete RPCs, where they communicate via message passing. So that is a much easier API to port around. Because even if you take, say, JSON RPC over HTTP, okay, so send the JSON blob over this DPDK message passing. And then you don't need to change a lot, and you get giant performance uplifts because you now have, say, full hardware acceleration of your encryption, and if it's gzipped, your compression as well, compared to what most HTTPS JSON RPC looks like. So this means cutting out some layers of the stack that I think some people don't realize aren't actually necessary.
Okay, so that means you're going to strip the certain layers in the conventional database deployments and then...
Yes, so this would involve source code modifications.
Yeah.
And some work by both the MockNet team and by the RPC team acknowledges that as long as you make it not that hard, most people will be willing to port to a different network stack, provided there isn't a big API mismatch. And one of the things I wanted to make as a point is that TCP as, say, POSIX sockets is a massive API mismatch for the way a lot of applications are written now, because they actually communicate via message passing, and then the fact that it's message passing over TCP is a detail they don't even think about.
Okay, thanks.
I'm glad to see that somebody's actually getting some traction on this. And a couple quick notes is one thing that I would also think that's a problem is the DPDK architecture threading model may be intrusive onto these kind of applications, as in they really don't want a thread pulling there. And by the way, if the thread that created the request becomes something that goes into a database request and is going to storage, you're going to get head of line blocking on the things waiting on the next thing on the receive queue. So you might want to kind of develop some kind of split brain thing where there's workers to pull things off and, you know, scheduler at the back end to send to other things if you have to go to anything slow.
Yes, so a lot of more modern databases are architected in layers. So you will have sort of network workers,
Right.
and then you will have things that do query processing and query optimization. And then you will have things
Right.
that only talk to the disk. So
Yeah.
DPDK application,
All right.
SPDK.
And then-
we can work on SPDK later.
Then the other question was, if you can, send message and receive messages are on the way out to be replaced by IO ring. And, you know, Linux did a bad job relative to, you know, VMS, even Windows NT, in terms of being synchronous and then finally trying to be asynchronous. If you've got a chance to do new APIs, you're better off to start out doing a ring-based asynchronous.
Yeah, so when I say send message and receive message, I mean take the function name.
Okay.
Leave everything else where
Yeah, because like IO ring has like send messages and op. You put in IO ring and you tell it to do something, and then it just guarantees it'll do it and tell it when it's done. It doesn't have to block on send message.
Yes, so for a DPDK send message, it could
Yeah.
be that it will go and put it in a buffer, and if the buffer's full, enqueue that
Yeah.
batch. So the semantics of the API, as long as it is vaguely, this is bytes I want to eventually end up on another server, and I would like some bytes from another server.
Yeah, it goes all the way back to your slide one. The mechanics of complaints about TCP are as much a complaint about the mechanics of POSIX sockets.
Yeah. Yes, I'm saying give people sort of a handle of familiarity.
Okay.
Like someone looking for, how do I send a message? We'll see send MSG
Okay.
and think, okay, that's probably where I should start looking.
Okay.
Even if everything else ends up getting changed and it has a different return value and it takes 20 parameters, they'll at least know this is where I start.
Okay.
Yeah. So thank you very much. I would love to come and collaborate with people. I'm not a hardware person, so I would like to work with some hardware people to design something that is actually going to be feasible for vendors to implement as partial or full offloads. Because I really think building from the hardware on up in a way that the DPDK community is uniquely suited to do will produce something that is better than what we currently have.